Hello and welcome. My name is John Wiedemeyer. I'm going to be giving the presentation on NVMe Protocol Analysis features for storage development test. I'm a product marketing manager for Teledyne LeCroy, and I've been very active with the PCIe SIG and NVMe promoters group for the last several years. Today we're going to be talking about several new pieces of new features that we've added for the PCIe Protocol Analyzer exercise or product line here at Teledyne LeCroy. I've included here kind of a brief agenda of the items we're going to go through today. But I want to just highlight the fact that here at Teledyne LeCroy, our goal is to maximize customer satisfaction by listening to your various feedbacks regarding new features you'd like to see in our products. And so what we see here is a representation of a lot of that feedback to help you in your debugging needs. First off, let me start off by saying that we have had an existing PCIe Protocol Analyzer line for some time, and we recently introduced a new protocol analyzer, the Summit T34, which is a PCIe protocol analyzer, but we've added some new features to this particular piece of hardware to assist with your storage needs. Just kind of giving some brief features here. This particular analyzer has our deepest buffer memory of all of our product line, and we'll talk a bit more about how you can optimize that to do some good testing. This protocol analyzer, as all our protocol analyzers, can support NVMe, SATExpress, and SCSIExpress. And but you'll find that this particular protocol analyzer, because of its small size, portability, and deep memory, is ideally suited for the storage industry. In addition to a protocol analyzer, we also offer some specific interposers and probes to help you connect to your various backplanes with your storage devices. So, for example, we have a 90-degree rack mount for rack mount systems. We have both the left and right side for that. We have your standard interposer for CHEM type of devices, and we have an M.2 interposer. We also have an SFF 8639 supported interposer for both 5-inch and 12-inch bays. I want to point out that recently there's a new name being added to this, a U.2 feature, so we have that support as well. At this point, I would like to talk more in detail about the software of this product line. And before I go forward, I want to mention that when it comes to protocol analysis, being able to look at the data is extremely important. And so we want to offer users as many possible ways to look at the data as possible. Many of you are familiar with the standard CATC view that we have supported for many, many years on serial protocols, high-speed serial protocols. And we think that the CATC trace view is certainly one of the best ways to do that. And you've probably seen this many ways. Basically, packets are listed here, and different colors help you to understand the various fields and error conditions that might exist on the bus. Users really enjoyed that, and but they wanted the ability to show even more information on the page. So we now offer a new feature by selecting one of the icons at the top there. I'm showing there, a compressed CATC trace view. And so this allows us to compress those same packets that you see and get more data on the screen. So we think this is a highly effective way. However, recently, over the last few years, customers have been who have come from the storage sector have really wanted to see things more in a spreadsheet view. So what we've done is we've created yet another view alongside of the CATC view that allows things to be listed in columns, or spreadsheet view as it's commonly called. And we've offered our coloring capability there. So instead of looking things at vertically listed, we can now look at things here in this columnized view. And I want to point out here that this is completely configurable. You can take any of the columns and move them around how you want them to be. You can delete them, add them. You can optimize this in any way you want to make it look to whatever familiar application you may be using today. Anything you're doing with that one, you can do with ours. And so this field, this particular view is, like I said, very, very configurable. We also have had some feedback that maybe color is not what you want. So in that case, we've offered you a black and white view. So you get the same information, but without the color. Once again, just by hitting a button, you can go back and forth and see the same information in just a different way. So once again, completely configurable. To assist with the spreadsheet view, we've offered also a detail view. This basically takes each particular packet and shows you all the different fields. You can drag and drop these fields into the columns or into the spreadsheet view and create new columns and see and detail exactly the view you're looking for. Here's an example of 3 windows that are set up around the spreadsheet view. You can see the spreadsheet view in the middle there and the various columns. And then to the right of that, you can see the detail view. And once again, all I have to do is take my my mouse and move any of those fields into the column area and create new columns and move those around. So here you can also see that the one window is, or the application view can show 3 windows at the same time. So here you see the spreadsheet view, you see the detail view, and at the bottom you can see a data view. Once again, there are many other views you could add there, but here I'm showing that the capability for showing 3 windows at the same time is pretty possible. To assist our storage developers, we need to add more information, especially the way people like to see performance into the spreadsheet view. So once again, we've offered in our detail view ability to list IOPS. So we can bring those over, like I'm showing here in this red square. You can see that the IOPS column is created. And so every packet has the performance per packet. We also have in our CATC, our standard CATC view, you can see that in our metrics field, we can expand that, and it also shows, in addition to throughput, latency, and response time, the IOPS performance metric. So once again, we've added IOPS to multiple places in our analysis views. Many of our users have really made use of this feature, the LTSSM flow graph view. The flow graph view has been around for many years, and it's kind of one of the backbone for identifying faulty or the inability to go to link up situation. And each of these bubbles or states has basically a state value associated with them. And so we can see the progress as we go from polling and detect to a link up condition. What we've done here recently is we've added the low power state into this LTSSM flow graph. We've had the ability to show low power packets and clock requests, all that in the trace itself. But now we've added it to the flow graph so that you can easily see what's happening. And of course, the flow graph is also a navigation tool to help you find where these packets exist in the main trace. So by clicking a bubble, you can immediately hyperlink into the trace. So one of the things that our customers have asked us for is better ways to do searching. You can imagine with huge traces, there's always an interest to be able to find various items very quickly. We have offered a very exhaustive, very powerful Boolean search capability in the tool for many years. But now what we've done is we've added a new feature that allows us to, on our main toolbar, basically a place where you can simply type in information, that you're searching for, and immediately go and find that in the trace. So there's two ways this works. You can type in any number, or any letters, or any words that you need to, addresses, data, whatever you're looking for. Just put it right there in that toolbar, and it will find it. In addition, what I'm showing here in this red triangular box, or red rectangular box, is a list of all of the types of things you might find in this specific trace. If it's not in the trace, it won't appear here. So once again, it's just a quick way to see what's happening. Yeah. So once again, we have the quick search added to the toolbar, in addition to the other search tool that you see in the menu at the top of the screen here, right here in search. And so, so we think that this is a great way to help you find various items in your trace. One of the things that developers are always interested in is how can they understand more what the NVMe Queues are doing. So we spent a great deal of time trying to understand the best ways to understand queues and see them in the trace. I mentioned before that we have the CATC view and we have the detail view. And what I wanted to point out is that with the CATC view, we can actually find all the trace information you might be looking for. And we can break them out in a hierarchical fashion here. So we can show you, for example, the various NVMe commands. We can show you the queues. And we can show over here in detail view the queue numbers, the PRP information, LBA information, all the storage items you need. But we can show you which queues each of these types of functions are working under. So if you have multiple queues in your trace, you'll be able to see everything that's happening with them. Another feature that's come, it's kind of upcoming in the marketplace, is the precision time measurement, or PTM. PTM is basically a precision coordination of events across multiple servers within independent local clocks. Anyway, so what they're trying to do here is, with IoT, you have all these servers out there, and you need better ways to coordinate your efforts and timing with all these various different timings that may exist in localities. And so all this messaging occurs through PCIe. So with the Protocol Analyzer, we have now provided a lot of this messaging to be decoded and shown in various views in the Protocol Analyzer. So you can see here that these different PTM message packets are decoded and shown. So on the protocol exerciser side, there is interest in, of course, being able to emulate this kind of capability in test situations. So the Summit Z316 exerciser can be configured to generate these messages, also receive messages. So depending on if you're in device simulation mode or in host mode, you can do testing in both areas. Another area that's become very important is security. The TCG group, Trusted Computing Group, has created some new encrypted security that's being used in storage. The Teledyne LeCroy CATC view has a capability to decode things like method calls and various security commands that exist in transmission between a root complex and an endpoint or an SSD. And so what we're showing here is a decode where we show the raw data view, and then we show the decoded data view format that's coming from that. If we go to our TCG Detail View, we can see all of the different fields that exist there, and then we show the decodes and kind of definitions of what's happening there. TCG can be quite complex, and so an analyzer is a great way to help you understand exactly what traffic's happening there, and so that you can verify that it's operating according to spec. You combine both the CATC view and the TCG or Detail View, you can see that you get all the information you need to understand packet by packet as it comes across. Now let's go on to a very important topic, triggering. Triggering is something that we continue to expand and work on it depending on what our customers want us to do. And one of the things that has been a request for a while is being able to do per lane triggering. So we've now added this functionality, and it can be enabled by selecting this icon here to the right. And we can basically trigger on items like DLPs, TLPs, symbol disparity, block errors, define and ordered sets. And I'll show you exactly how we can do that. So, for example, in this particular screen, this is where we define our lane trigger configuration. We can look at DLPs and TLPs that start in any of the upstream or downstream directions at the 0, 4, 8, 12 lane numbers. And so, just by selecting one of those lanes, it will basically trigger on any DLP or TLP that appears on that particular trigger. Here, of course, I've selected all of them, so it's going to trigger on anything. But if I select any one of those or combinations, it will be triggering on any type of a DLP or TLP that pops up on one of those lanes. Selecting another tab here on the same screen, I can now search for symbol and disparity and block errors. Once again, the principle is similar, just by selecting the lane I want in the upstream or downstream selection. I can trigger on a symbol or disparity block error that occurs on that specific lane. The lane configuration screen also shows the ability to do an order set trigger, and here we can basically select upstream or downstream the specific lane that we can trigger on. This particular screen requires some setup. We made some changes in this. In the old way, we had within the event properties screen, we had the ability to select a specific lane. However, it was a little more cumbersome to use, we thought, and so we moved to this new control. And all we have to do now is basically select the use lane trigger under the lane number pull-down. And by doing that, and then in combination with the set screen, we can now trigger on a particular lane and find that first set. Something new that we're very excited about is this Trace Expert. The storage industry has been searching for a great way to be able to provide an analysis and basically an overview of the functionality and performance that a storage device might have. And we have created a Trace Expert feature, which is basically a port and an analysis within the Protocol Analyzer. And so what I'm showing here is a screen that allows us to set up the kind of reports that we want to generate from taking a trace. So once again, a user would take a protocol trace of his SSD or whatever piece of equipment he might have, and selecting which of those tests he wants, or maybe all of those tests. He can learn about performance analysis, the trace analysis, error reports, and of course get a trace information component to it as well. And I'm going to show some of the kinds of reports that a user can get by using this Trace Expert. When the report is generated, an HTML file pops up that basically you can use this to the right here, these arrows to help you navigate through each of the individual reports. Once again, the document device and system performance and status are all broken down and illustrated and shown in each of the pages of this report. So, for example, in the performance analysis, I see a breakdown of the link transaction performance. And if you look at here, the various columns, I'm getting all kinds of good metrics out of this. And if you were to scroll down, you would go on and on for pages, giving you all kinds of this information. Now, what I'm showing you here is a report that comes out, an HTML report that comes out that you could use and include in your own reports. The same information is also within the Protocol Analyzer, so you can actually look at it, Protocol Analyzer, and see what's happening there. You can see here as we move across here that we have things like link and split transaction count, NVMe transaction count, throughput speeds, response times, latency, and IOPS speeds. These are all supported for NVMe devices. And we can go on and show you more detail on the various NVMe queues and read-write commands and all the information that our customers have been asking for when they're doing their basic testing. Statistical analysis is also available. You can see here that we can look at both the upstream and downstream totals for a wide range of items that appear within a trace. Analysis is once again an important part of the Trace Expert. So not only are you getting counts, but you're going to get a lot of detail with, for example, doorbell registers and NVMe transactions. I've listed here some more various pieces that you can find in the report. So once again, a lot of people are interested in trying to understand and the operation and performance, what's happening with their submission queue, tail doorbells, and headers, and completion queues, and implicit, explicit doorbells. There's just a lot of information that people are always interested in, and so we've done a tremendous, I think, effort to try and find all these particular items and gather them together in this analysis report. Once again, more error reports. So we've gone through and made these huge lists of any potential things that you could find in the spec, or things that various companies have been very sensitive to. They're all part of this list. And of course, at the end, we provided information about how this report was gathered and what dates and what equipment it was all there. So once again, by just simply performing a Trace Expert and building this report within just a short time, you now have a document that records the performance of your device, something that you can document with your management about what's happening. So we think this is going to be a very important tool within the storage industry. So something that continues to be interested is that when we're gathering information, people want different ways to look at it. And so what we've done is we've added some more graphs and measurement capability. With the various queues that people are encountering within storage testing, they want to be able to view submission and completion queues. They want to see if queues are being overloaded. They want to make sure that there's even number of submission and completion queues, and that things are not working poorly. And so what we've done is we've created this queue utilization graph within the timing calculator. So you can see this little tab up here. Just selecting that and running the report gives you this this nice visual way of seeing the health of queues. So we think that this will be very valuable to those who are trying to explore issues about why this overloading might be going on, or why some queues are favored than others, and be able to work out all those issues around operating systems and drivers. Also, within the timing calculator, we've added this new NVMe transaction summation report. And so once again, if you look here, you can see a link split total traffic showing you the various transfer payload byte numbers. And you can also see here this NVC, which is NVM command total traffic. So once again, we're going to give you some numbers on read and writes, and you can see this per device. So once again, another way to get this information. This kind of information, once again, is also gathered up into the Trace Expert report that I previously talked about. We have had the ability to show graphs, and I have a list here up in the corner showing the various reports and graphs that we've had. But we've now added an NVMe command IOPS report graph, and you can see here that just by invoking that, you can configure this and get that kind of visual information about how your NVMe command IOPS performance is doing. We've done the same thing for the SAT-Express or ATA, and so what you can do is just, once again, just select the graph and you can get that information built up in the graphical view to go along with your data. We've added ability to show various queue errors, so things like duplicate doorbells, rollovers, non-existent completion queues, non-existing submission queues, writing to a full queue, reading from empty queue. So these are various errors that are out there. We now show those individually. And
Muted. Unmuted.
If you look at the side here, these are all metric reports that you can show within the Protocol Analyzer. Of course, all this is also built into or sent to the Trace Expert report as well. But here we can individually choose them and look at them within the analysis in the Protocol Analyzer. These have been around for the last several versions of the software since last year, and but we added something new here, this queue time metrics, and I want to really highlight what we've done here. This is something really I think is useful. If you look at this report on the very left-hand side, you see the queue. This is going to specify which queue we're talking about. So here we have 5 queues, and you can see that we're going to show you some min and max and average times here, and going across. Now I've got some abbreviations here, and I know it can be hard if you're first seeing this, but what I've done is I just kind of spell them out here. So an SDBL is a submission doorbell, and likewise below. So for example, here we can see a submission doorbell to the completion doorbell minimum time here. So once again, you can actually walk through each queue showing various timings and see the exact health of that queue in terms of its timing. So if it's not something you expected, it'll come up in this particular view of what's happening. So each individual queue can be seen in its entirety here, at least from a timing standpoint. So in addition to this traffic summary report, we've added the same information to our packets in our CATC trace view. So here we have, once again, the submission doorbell to the completion doorbell within the metrics field of each individual packet. So anyway, this is, we think, very useful. So now you have various ways to get this information. Once again, all this information has been added to the Trace Expert report as well. Something that we've been working on, and we now have this capability, is the ability to do an optimized trace buffer based on a link width selected. So in our recording options screen, you look at the far right here, you see a pull-down menu with various link width capabilities. So for example, if you wanted to do by 4, by 8, by 16, you could choose each individual one. However, with this new optimized trace buffer, by selecting the closest lane width size to your particular application, you will see a reduction in lock times. And so what we're trying to do here is make this as specific as possible. So if you want to do this, you can. Selecting any of these will automatically do it, but by knowing in advance the exact lane widths, you can now once again reduce lock times and of course get an even tighter recording than in the past. Now we have a new feature that I think is going to be very, very useful for the entire storage industry. In the past, protocol analyzers, the way they worked was that they needed to have long periods of recording time. And with PCI Express protocol analyzers, this has been a challenge in that because of the high speeds and the amount of memory, things like that, that recording times have been very, very limited. With our new NVMe Enhanced mode, we can now extend those recordings to 30 minutes. Now, I want to point out that this particular feature is available only on the Summit T34. And so the other analyzers, although they can do some recordings that are fairly lengthy, they do not approach anything close to the Summit T34. So using Summit T34 and this special NVMe Enhanced mode, you can now get traces that can be 30 minutes up to a couple hours, depending on how you configure the recording. Once again, with this feature, you'll be able to do measure performance over long periods of time. You'll be able to see how queues are distributed over a sustained period of time, not just a couple of minutes, but now over an hour. And you'll be able to find those intermittent errors that pop up only once in a blue moon. And so we think this is going to be something that people will really, really need in their labs. Just to give you a little more detail about it, to set this up, once again, you need to have a Summit T34. You just select the NVMe Enhanced mode, and in this red box here, what you'll do is you'll be able to select various items that you want to record. And so it's fairly simple to use, but once again, it's on the Summit T34 that this feature exists. So at this point, I've introduced a lot of new features that we have on our website today that you can download. If you take the opportunity to go to the Teledyne LeCroy website and go to the Protocol Analyzer for PCI Express, you'll be able to find the software and play with it on your application. And anyway, enjoy to hear some feedback on that. What I want to do now is I want to open it up for some questions. So if you have some time, you could send me some questions through your chat, little chat box on your screen there. I can take a few questions at this time. So we have a question. Does the Protocol Analyzer support decoding implicit and explicit doorbells in the trace? Yes, this is a new feature that we recently put into the 7.36 beta that's up on the website today. Yeah, looking for another question. Hey, another question. Does Teledyne LeCroy have any compliance tools for NVMe? Let me explain this a little bit in some detail here. Today, the only NVMe compliance or conformance tools are offered by the University of New Hampshire, the interoperability lab there, and they make basically a set of tests. They have selected the Teledyne LeCroy Protocol Analyzer and Exerciser as the de facto standard tools that run their conformance scripting tools. These same tools are used at all of the NVMe plug fests that are held twice a year. Okay, anybody else have any questions? Okay, well, thank you for your time. And once again, I'm always available. If you see me at any of the plug fests or want to write me an email, you're welcome to do so. And once again, I'm John Wiedemeyer, and hope you have a good day.